Science 10, Lesson 8, Naming Covalent Molecules. Covalent bonding. Covalent molecules form when two atoms looking for electrons meet. Neither is strong enough to steal an electron, so they decide to share electrons. When electrons are shared, a bond is formed. There are two types of covalent naming that we have to be familiar with. The first type of covalent naming we will discuss is that of the diatomic molecules. These are elements that often pair up rather than be alone. They should be highlighted on your periodic table. You should also write the word diatomic somewhere on your sheet and highlight that word as well. So in the future, you know why these elements were highlighted in the first place. When naming a diatomic, the name is written exactly as it is found on the periodic table. Our first example is O2. And when we look up O on the periodic table, we see it's been highlighted. And since it's a diatomic, I call it just oxygen. And you're probably familiar with this because in biology at some point, you've heard someone say that we breathe in oxygen, which is O2. And if we see the formula O2, we write just oxygen. Diatomics are never found on their own. If found alone in nature, they will immediately bond with another element identical to themselves. So if we had an O all by itself in nature, it will find another O that is all by itself. They will bond together and float around just as O2. So anytime I say oxygen, we see it's highlighted, we write O2. If we see O2, we look on the periodic table, we see that O has been highlighted, so we just name it oxygen and nothing else. Example 2 is nitrogen. I go to my periodic table, I see nitrogen is a diatomic, so I can't write just N. Since it's a diatomic, I would write then N2. Example 3, I have F2. I go to my periodic table, I find F, I see it's a diatomic, so if I have F2, I call it just fluorine. Example 4, I have iodine. So I go to my periodic table, I find iodine. It's been highlighted because it's a diatomic, so therefore I can't write just I would have to write I2. Naming covalent molecules. Covalent molecules. They're made of two nonmetals. They use a covalent prefix to identify the number of each element present. Note, there is an exception, mono. It is never used on the first element in the formula. And the end of the covalent molecule name is always changed to "ide." Start by finding the covalent numbering data table on your formula sheet. Then, by covalent, I would probably make a note that says "ide," since covalent molecules always end in "ide." And I would probably write two nonmetals, since covalent molecules are always comprised of two nonmetals. Example 1, C2O4. I have two C's. The covalent prefix for 2 is di. So 2 carbons is called dicarbon. Then I have 4 oxygen. The covalent prefix for 4 is tetra. So 4 oxygen is called tetraoxide. Remember, we changed the ending to "ide." So C2O4 is called dicarbon tetraoxide. Example 2, PCl4. I have 1 P. The covalent prefix for 1 is mono. So 1 phosphorus would be called monophosphorus. But there's an asterisk next to mono because mono is never used on the first element. So we just write phosphorus. Then I have 4 chlorines. Covalent prefix for 4 is tetra. So 4 chlorines is called tetrachloride. So PCl4 is called phosphorus tetrachloride. Example 3, P4O6. I have 4 P's and the covalent prefix for 4 is tetra. So 4 phosphorus is called tetraphosphorus. Then I have 6 oxygen. The covalent prefix for 6 is hexa. So 6 oxygen is hexaoxide. So P4O6 is tetraphosphorus hexaoxide. Example 4, carbon dioxide. I don't have a covalent prefix on the first element listed, but that's because I only have one of them. Remember, mono is never used on the first element listed. So since I have no covalent prefix in this covalent molecule, that means I have just one carbon. Then I see dioxide. Di means 2. So dioxide, that means 2 oxygen. So I write O2. So carbon dioxide is CO2. Example 3, P4O6. I have 4 P's and the covalent prefix for 4 is tetra. So 4 phosphorus is called tetraphosphorus. Then I have 6 oxygen. The covalent prefix for 6 is hexa. So 6 oxygen is hexaoxide. So P4O6 is tetraphosphorus hexaoxide. And that's the end of the lesson. You're good to move on to the assignment.